We're going to focus on 10 scenarios related to the single sample t-test. To begin, we'll click on the Start button. So we're asked to evaluate the scenario. To retain the null, we'll click on the scenario card. Otherwise, we'll click on the Reject the Null card. Here's a scenario. Compare a sample mean to a known or hypothesized population mean. The population is fairly normally distributed and sigma is unknown. And our degrees of freedom is 15, so we're dealing with, a somewhat small sample size. So we're going to be using that single sample t-test. Our null hypothesis is that the sample mean is equal to the population mean. So this is a two-tailed test. The sample mean was 102.27. The population mean was 100. So that's a small difference, but should we consider it statistically significant or not? To determine that, we'll take a look at the t-test. It's 0.62. That's a really small t-test value. Looking at the p-value for this two-tailed test, it's 0.545. That's larger than our alpha level of 0.05. So we're going to retain the null hypothesis. This is not a surprising finding. It can happen quite frequently, so again, we retain the null. Now, for this scenario, you'll notice that our sample size is 48. This is a large sample size. And even though the sample is only somewhat normally distributed and sigma is unknown, based upon the Central Limit Theorem, we can actually go with the z-test. We can do this because regardless of the shape of the distribution for the individual scores, by the time you get to the distribution of sample means for a sample size 30 or larger, in this case 48, it's going to very closely approximate the normal distribution. Also, when you have a sample size of 30 or larger, your estimated standard deviation is going to be really close to the population standard deviation. So in this case, we get to use the z-test. So our null hypothesis, sample mean is equal to the population mean. So we're looking at a two-tailed test. The research hypothesis would be that they're different. Sample mean is 104.44. Population mean is 100. Our z-test is 2.48, meaning there's approximately 2.48 standard errors between the sample mean and where the null hypothesis says the population mean is. That's a big difference. The p-value for our two-tailed test is 0.013. That's less than or equal to our alpha level of 0.05, so we'll go ahead and reject the null. Okay, we have another scenario where because our sample size is larger than 30, we can go with the z-test. It's going to be a one-tailed z-test where the null hypothesis says that the sample mean is larger than or equal to the population mean. We take a look at the evidence, and the sample mean was actually smaller than the population mean. It was 97.56 compared to 100. The z-test is a negative 0.97. That's not a very large z-test. Based on, we're probably going to be retaining the null, and we look at the p-value for this one-tailed test. It comes out to be 0.166, and that is not less than or equal to our alpha level of 0.05. So we're going to retain the null. We'll click on the scenario card. Another case where we have a large sample size, 32. We have a two-tailed test. The hypothesis that sample mean is equal to the population mean. The alternative hypothesis would be that they're different. The sample mean is a 93.67. Population mean is 100. Our z-test is a negative 2.65. So that's beyond the cutoff of plus or minus 1.96. So based on what we know, we can reject the null. But let's look at the exact p-value for this two-tailed test. It's 0.008, which again is less than or equal to our alpha level of 0.05. So we'll reject this null hypothesis. We have another example with a large sample size. It's two-tailed. Sample mean is 104.55. Population mean is 100. Z-test is 2.04. The p-value for this two-tailed test is 0.041, which is less than or equal to alpha level. We reject the null. All right, now we're working with the sample size that is somewhat smaller. Degrees of freedom is 18 here. So the null hypothesis says that the sample mean is larger than or equal to the population mean. We're looking at a one-tailed test here. Sample mean is 91.97 compared to the population mean of 100. So the results, our evidence, actually went in the opposite direction of what the null hypothesis specified. So it's possible we're going to be able to reject the null. The t-test is a negative 1.84. The p-value for this one-tailed test is 0.041, which is less than or equal to alpha level, so we reject the null hypothesis. Here our null hypothesis is that the sample mean is less than or equal to the population mean. Sample mean is 105.82. The population mean is 100. So the results here are not what the null hypothesis is specifying. It's going in the exact opposite direction. So it's a good sign. The t-test is a 1.76, and our p-value for this one-tailed test is 0.050. That is less than or equal to our alpha level, 0.05. That's as big as a p-value you can have and still reject the null hypothesis. So we reject the null.